So today I will tell you today's agenda. So roughly, basically, I'll just summarize what we intended to cover in sorting and how much of that has been covered, and what we intend to cover today and close out sorting, at least the theory as well as some representational questions on it. So there are basically three type. I mean, there are two phases to this uh, sorting classes that we want to conduct. One is the iterative sorting and the recursive sorting, right? So the recursive sorting basically comprises of merge sort and quick sort at primarily amongst other algorithms. And iterative algorithms, I guess you already know. You have selection sort, you have insertion sort, you have what else? You have bubble sort, then you have count sort, counting sort, you have radix sort, and then you also have bucket sort. So this phase will basically, if you see the timeline, there is one lecture that is dedicated to this. So we will cover this in that lecture, as well as look at some applications wherein we tweak these algorithms to a certain effect, and we get some desired output that we want. And this is primarily this was the objective of the two lectures that was scheduled. I mean, one that Manvi took, and like a couple of them which I am taking. So in this, basically, we wanted to cover at least these three things: the theory of all these algorithms, then some applications. So sorting is mostly about applications. So questions wherein explicit sorting is needed, and you use that sorting to solve a particular problem. That's another. And then we wanted to cover sorting in STL. So how sorting is done in STL. So this was basically the agenda of the entire sorting classes, the three classes that were scheduled. So this, I guess we are covered. You don't have any questions, right? I'm assuming. So this, I guess we are good. I can double tick on this. This, some of it was covered by Manvi in the day before yesterday's class. And some of it will basically be covered in the doubt class after you do some questions. Okay. In terms of theory, I am guessing at least these three sorting algorithms you are good with, right? So our goal today is to talk about these three algorithms and some applications of these algorithms. Okay, and that will basically wrap up this entire segment of sorting. And then after that, we will basically be covering recursion. If you see the timeline, I will be taking 3 classes on recursion scheduled to start from the day after tomorrow. So we will have 2 recursion lectures, and then one lecture on dynamic programming, which will be an introductory lecture that will set the tone for DP. That will be covered later. And then after that, we will be in a good situation to discuss merge sort, quick sort, as well as some of its applications. So this time, so is there any questions with respect to this timeline? Or this detailing? Any questions or any? Yeah, counting we can skip. Okay, that should be fine. I guess people had some questions on counting sort. That's why I thought I will recover it. But if you guys are fine, we can skip counting sort also. That shouldn't be a problem. Other than that, is there anything else you wanted to cover in sorting? I guess that's broadly basically everything that needs to be covered. Shell sort is not important, Aswitwa. I mean, nobody asks, at least as much as I know, it's not really needed. If you see heaps, these are data structures, right? So we have not yet started data structures. Just look at the timeline. You have all the data structures. You have heaps by BSTs and heaps BSTs and hash tables in 3 lectures that I will be taking, and then you have heap sort. Heap sort will be covered then. Yeah. Heap sort will be covered when we talk about heaps. Okay. Yeah. Otherwise, like, it does not make sense, right? How do you teach heap sort without teaching heap to people? Yeah. So yeah, so that is broadly basically the entire distribution of sorting lectures. Any feedbacks on this? Any questions? Anything extra you want to include, please let me know and I can take it up. Is everyone cool with this? Can I have some acts? Maybe some of them. Topological sort again in graphs we will be covering. Okay. All right. So do you want counting sort to be discussed again, or are you guys fine with counting sort and we can skip to directly radix and bucket sort? Yeah, everyone is fine with counting sort. Okay. If everyone is fine with counting sort, we can skip counting sort. Yeah, we have two questions that I intend to discuss. Those are good questions. We will discuss. Don't worry about it. So if you see, I think Manvi discussed one application of counting sort wherein there were three colors, 0, 1, and 2, and you had to separate them, right? So that is like primarily that is basically what counting sort is at a very high level. We will discuss one very hard application of bucket sort today. So it might go above your head, but I'll try my best to explain it to you guys. That's like a classical, application of bucket sort, which is asked sometimes in interviews, not always.
Hello.
Yeah, Rahul.
Sir, in counting sort, there was a problem given by Manvi ma'am that was of color sort. I don't remember the question name. That was the first question.
Yes.
In that question, at the last, in the follow section, there was written that can we do that problem in a single pass?
Yes. Do you want that to be discussed? So that is basically a modification of quicksort. So we can either cover it as part of once we discuss quicksort and how we pivot around, how we distribute elements around the pivot, or if you want, we can discuss it now. But right, do you want that question to be discussed, people? Yeah, while doing quicksort, we can discuss, right? That should be fine. All right. That is a natural transition into, like, that makes more sense once you have the pivoting algorithm or the partitioning algorithm around quicksort. It is, I mean, you can name it various things, 2 pointers, 3 pointers. There are some other names also to this algorithm, but yes. Tries will be covered in strings. Ashish, segment trees, if you want, we can cover. There was no intention behind in covering segment trees, but yes, let's take that up in the group. Okay. Yeah, let's take it up in the group, not now. Okay. Segment trees we will cover them if you guys want. That should not be a problem. All right. So let's start with a question quickly, and then I will delve into some theory just to warm up you guys as well as. So all of you are pumped up. Nobody is like sleepy. You just had a contest, right? All good. Do you want me to wake any one of you? No. All right. Yeah, because I'm not seeing a lot of like involvement as of now. Maybe with time it will. So let's do the question that I gave you yesterday. That's a good question. And then after that, we will talk about. So did you have a chance to do this question? I will just tell you the question. Essentially, what this question is telling you is basically that you have an array of numbers. You have an array and you have numbers in this array. And what you have to do is you have to find out whether you can partition it into sets of size k. So there should be sets of size k, and each such set should only comprise of consecutive elements. Okay. So for instance, if I say k is 2, I can say that yes, it is possible to partition this into sets of size k. What will be those partitions? 2, 3 will be in one partition, 4, 5 will be in one partition, 7, 8 can be in one partition, right? So these are like, if this set, if you see, every element is consecutive. This set you see, all elements are consecutive. This set you see, all elements are consecutive. What is the size of each set? Which is equal to k. Here it is 2, right? On the other hand, if I take an example, let's say of this type, let's say just 2, 4, 5, and I say, and 6, let's say, and I say k is 3, can I, or let's say k is 2, can I partition it? No, I cannot partition it into sets of size 2. Right? Does everyone get the question? Yeah. So do you have any ideas around how we can do this? Can you just think out aloud? I will give you my thought process. So that's also one of the things that I try to do in my classes, basically giving you what is going on in my head when I get a question of this type, or get any question for that matter. Any ideas? Any suggestions? Okay, Rohan, that's good if you did it using maps. How can we do it using sorting? And that's actually a better algorithm than doing it using maps, which you will realize. But I want to sort and do something with this. Any ideas? Okay, I will just give you one hint. No, not 2 pointers. I will give you one hint. Think about it. So assume that I have sorted the array. So now I have an array with in sorted fashion. All right. Let's say I sort it and I get something. Let's say this is the sorted array. Think about the minimum element and think about the set it can go to. If you have many sets here where you can put, so you can put, you will basically partition it into k sets of size k, right? So think about the set that this minimum element can go to. And can you decide something? So this minimum element, first of all, do you agree that this minimum element can only go into one set? See, first of all, every element can be a part of only one set, right? There is no doubt about that. So think about the minimum element. If the minimum element, let's assume, okay, let's assume that it is possible to have this kind of a partition. Okay. If it is possible to have this kind of a partition, it will be the first element. Yes, that's right. If it is possible to have that partition, think about the set where the minimum element is present. What will be the property of this set? Or what will be the pattern that I can see?
Sir, here 2 plus k minus 1 numbers will be present, means the maximum element will be 2 plus k minus 1.
2 plus k minus 1. What is 2?
Means the minimum element plus the number of partitions is k.
Number of partitions is not k. Size of a partition is k.
So, sir, the size of partition is k, then 2 plus k minus the minimum element plus k minus 1.
Think about what, yeah, Utsav is actually right. This set basically, don't you think if it is possible to partition it, this set will contain the first k elements of the sorted array? Do you agree?
No, sir.
If it is possible.
The k distinct.
K distinct elements, right? First k distinct elements of this.
So if 2, 3, 3 is present, then we can't take both.
Yeah, I got it. You are right. You are right. That's what I intended to say. I wanted you to correct me. So what I'm saying, Tushar, is that think about the first element, or think about the minimum element and the set that it can go to. This set, won't it contain the first k distinct elements of this array? Right? Does everyone agree to this? No rocket science in this? So now I tell you that isn't the algorithm basically telling you that pick the minimum element? Okay. So what if I have an array of this type? Let's say I have every element with its count. So this is the element and this is the count. I will tell you, Pradum, why maps are bad or not as good as this. Let's say I have an array wherein every element of that array is a tuple and I have the element along with the count. So can I say that the first k elements of this array will basically be present in the first set? Right? If it is possible. I mean, these will also be consecutive. We will have to take care of that as well. Right? And then what if I tell you that, okay, what can I do is, can I have a constructive algorithm for this, wherein what I do is I will put them in this set. So how will I put them virtually in this set? I will decrement the counts. Correct? Once I decrement the counts, can I repeat again? Until I have exhausted all the elements. If at any point I am not able to put that in the set, then it's not possible. Right? Does everyone understand the algorithm? Any questions? Which part, Ishan, do you want me to repeat? Which part? Till where did you, were you able to follow? Yeah, so I'm telling, let me have an array wherein I have pairs with the first element of the pair being the element itself and the second element being the count of that in the array. Okay. Once I have that, can I say that the first k elements of this array will be in my first set? And once I have that, can I decrement my counts for these first k elements and then repeat? At any point, if I'm not able to find a set, then it's not possible. Or if I exhaust all the elements, then it's possible. Yes, this array is sorted. Cool. If everyone follows, I will quickly show you the implementation. So the reason I took this question is I just wanted to show you some more C++ code. This is a little more implementation heavy. I mean, not as much, but yes, it is. So then let's do that. So the first part of the algorithm is basically, let me sort the array. Okay. How do I sort the array? I can call the sort function with nums.begin and nums.end. I don't need any comparator function for this because by default, I want to sort it in increasing order. Correct? Once I have sorted it, can I create those tuples? These tuples are basically the element with its count. How do I create this tuple? Let me have a vector. Okay. Let me call this the count vector, count v. Now what I can do is I can iterate over this sorted array. And what will I do? I can check that if my count v dot size -1, if this last element, so this array first of all will be a pair. Now this is another data structure that I wanted to introduce. So this pair is nothing but a tuple, a way of writing that this is an array which comprises of tuples, right? This is a data type. And what are the data types of what are the data type of individual elements of the tuple? it's an integer, comma, an integer. Okay. This syntax is clear to everyone, all kinds of developers. No issues with this syntax, right? So I've just created this pair, and now I'm just iterating and accumulating the sums. So I'm just checking. I can access the first element of this through the dot first notation and the second element through the dot second notation. So what I will do here is I will simply check if the first I want to create the element, right? If this element is the same as the current element, correct? Then what will I do? I will simply increment the count. Dot second, I will just increment the count, correct? Otherwise, what I can do is what will I do? I will create an n, right? So I can push back one, and I have to create a pair. So I will write this syntax. Make pair basically creates a pair. And what will be that pair contain? The element and the count. Is this correct? Do you follow what I did? I just constructed the tuples array, the count v. Is anyone having any issues in this syntax? I can do that, yeah. Curly braces will also be fine. Do you want me to do that? Okay. Cool. Everyone is cool with this? This is correct, right? There is nothing else that needs to be done. What is the question, Rohit? Line 13. You don't understand the line 13? I can explain the if condition. So what I'm checking is, I'm checking that if, because this is a sorted array, I'm checking if the last element of this count v array, if the element in that last tuple is equal to the current element, I will simply increment the count. Correct? If it is not, then I will create a new. See, I'll show you. I'll tell you what I mean by that. So what I'm trying to do is, see, count v is an empty array to start with. So count v does not have anything to start with, right? What I will do is, let's say this is the array. 2, 2, 2, 3, 3, 5, let's say. Okay. What I do is, I construct this count v on the go. It is empty to start with. So when I encounter the first element, I have that check, right? What is the check? My check is that if this size, count v dot size, let's say cv dot size is not equals to 0, and there is a bunch of other things. I don't care about that. There is something, and then there is an else. So the first time I am looking at an element, it will go to the else. So what does it do? It creates the first element of the array of count v. And what does it initializes it to? In the curly braces, if you remember, I initialized it to num psi. Here I had num psi, comma 1. So here I will have 2, comma 1. Right? Now I am here. So what do? I check this if. This if is true. What was this if? This if was basically telling me that is this element equal to this element, the element which is at the last. And if this is equal, you just increment the count. Then I move here again. Again, is this element equal to this element? Yes. So I increment the count again. Now just think about this. Now I am here. Now what happens? Now I am here. I check, is this element 2 equals to 3? No, it is not equal to 3. So I go to the else part and I create another cell because I do a pushback, right, of 3,1. Then I'm here. I check if this equals to this, then I will increment this 2. Then I'm here. And again, I go to the else part and I create 5,1. And then I'm done. Right? Clear with everyone? Janvi, you had asked the question, right? Is this clear, Janvi? Yeah. Okay. So this is basically the first part. I have now successfully created this array. Now let's write the actual logic, which is difficult to write, but let's see. So what will I do? I will start with the first element. Let me keep the count somewhere. Let's say, let me keep the count as, let's say small CV size. CV size is count v dot size. Now I will just iterate over all the elements. Now just think about it. What I am doing is I will pick the first element, correct? And now I have to construct a set here. So let me do that and follow carefully. So let's say I say int element space cnt. So my current element is nothing but count v I dot first, right? And my count is count v I dot second. Now let me construct a set. So for that, what I can do is, let me start from I plus 1 till where I will go. I need k elements, right? So what will be this condition? Anyone? J less than I plus k, right? And now I am looping k times. Now there are certain things that I need to take care of. First thing is I need to check if it is consecutive. How do I do that? I can check if count vj dot meet, will it be equals? I am including this element also. So from I to I plus k minus 1, how many elements will be there? K elements, right? From 1 to 3, how many elements are there? 3 elements. Including 3 if you are doing. Yes. So count vj dot second, I will check, is this equals to, what should I do? ELT plus j. If it is not equal, can I return a false immediately? That means if it is not consecutive. Correct? Now I will check if it is consecutive, I will check if there are sufficient numbers of this. Yes, first. How do I check if there are sufficient numbers? I will check if count vj dot second, if it is greater equals to my count, then I'm fine, right? But if it is strictly less than the count, then there isn't sufficient number of elements, right? Because I have to finish off all the counts, like all the elements, right? So can I return false? Otherwise, what will I do? I can simply decrement count V by C and T, right? There are more things that need to be added, but do you get what I wrote here? Like roughly, once I complete the algorithm, it will become more clear. I can explain on the whiteboard if you want it to be.
Can you explain this consecutive part?
Yes, so what I did was I just clubbed many such. So what was the algorithm that I told you? The algorithm that I told you was you decrement count by 1k times and then I iterate. So instead of that, what I did was straight away exhaust all this count. So if there are 3 such minimum elements, I need to have at least 3 elements here, at least 3 elements here till k. Like at least 3 elements from that index to like for the next k elements. That's what I'm doing in that algorithm. Like, does that make sense? Prakash?
Sir,
So I've just clubbed that instead of like decrementing by 1 always, I'm just decrementing like taking.
Sir, I have a question. Like we have to make the set of size k, right?
Yes.
So what we can do is like we can divide the size of the original array by k, so that will be the size of each set.
Okay.
Then we will loop and then we will decrement by 1 so that is the same logic, right? That will work, no?
Yeah, that should work. I mean, I have to see your code. This is more implementation dependent than algorithm, right? So yeah,
like if n is 12 and k is 4, so we will have set of size 3. So the numbers are 2, 3 and 4, so there should be 3 2s. So that is what I'm saying. Like we can
again, if n is 12, that there should be 3 2s.
Because like if there are 3 2s, then in one set only 1 2 can come, right? So we need 3 2s at least, like, or 3 minimum things. Like that is what I'm saying. Like I will fill each set. I'll start by the first set, fill it with 1 of each, then I will start again from
Yeah, you can do that. That's what you can do.
So what will be the time like will this be more efficient than what I'm saying?
This will be in some sense like granularly big O of in big O notation. No, it will, I think it will nearly be the same. But yes, if you are just looking at it in a more granular level, not just computing the exact number of operations that are happening, probably this will have less number of operations, right? Because what I have done is I am not enumerating all the sets. I am enumerating I am enumerating the first 3 sets together in one set of operations, right? And then I'm enumerating whatever is remaining. So let's say this was 3, 4. I'm enumerating the remaining one set here, and then again, right? Do you get what I'm trying to say? You would have enumerated set 1, set 2, set 3. So 3 operations, and then you would have enumerated every set, right? Does that make sense somehow, Ishan?
Yep. Yes.
Yeah. I mean, it does not matter so much, so it's fine. So this is fine with everyone, right? I'm assuming this is fine with, is there anyone who does not understand this check 33? So I will take it as a yes then, if you guys understand it. So what else needs to be done? Line 30, Pradyum. I'm just checking if it is consecutive or not. The next element that I'm encountering is consecutive or not. ELT is the current element. So if it has to be consecutive, the first element will be ELT plus 1. The next one will be ELT plus 2. So this will be the right. This is what you're saying, right?
Sir, J should be less than equal to I plus K, right?
J should be less than
Because
equals
K
to
elements are there.
K elements. So we're starting from I plus 0. We are including I, right?
Okay.
So it will be I plus K. In the for loop 1, Middle condition won't have a parenthesis. Yeah. Okay. Okay. Other than that, this is cool with everyone. Yes. So now I have constructed the first set. Have I? I have not yet. I am yet to decrement my count of I, right? So I will do that. Dot second, I can make 0. Or I can decrement it by count. It's the same thing. Yes, I need to take care of that case. You are right, Bhupendra. I will write that. Okay. So there is just one case that is missing if I'm able to construct, which is if I'm here and I don't have k elements remaining. There is one thing here. First of all, here I can do if count is 0, I can simply continue. Correct? Now there is just one case that remains, which is basically that if I am at a current, if I am at an element which has a non-zero count and I don't have k more elements remaining, right? Which is what I have to do. So I will check if I plus k is less than CV size. Then I can, if I plus k is greater than the CV size, then I can return false. Right? Will this be enough? Come on, apply your gray cells, put on your thinking caps. And then can I just return true here? This condition everyone understands? Let me just submit the code, then I will tell you. Okay, so ask me questions quickly before we move on. Any part of this code you don't understand? Any syntax you don't understand? Any condition you don't understand? Line number 29, Shlok has a question. Okay, so see, in this iteration that we were doing, yes, Ashish, in this iteration, so see what we are doing here. We are doing, let's say you had 2,4, you had 3,6. Let's take case 2 to simplify things. Let's say you have 4,2 and you have 5,1. Let's say this is the case. We will debate that, which is better and why it is. So now if you see in the first pass, what am I doing? I will try to exhaust this, correct? So I will make this 0. I will make this 2. That's it. Till k I am doing, running, correct? So then I will be here and now I will try to exhaust two counts of 3, right? So I will make this 0 and I will make this 0, correct? Then I will come here and I will continue again because it is a 0. So now I will come here. So when I'm at a particular I also need to check if I actually have k elements remaining in the array. Right? If I don't have k elements remaining in the array, then I have to return false, which is what I was doing through that condition. Prakash and Shlok, you got it, right? Any more questions? No, right? Okay. So then this is done. Now tell me, is this better over a map? I mean, if people don't understand map, it's perfectly fine. or let's actually do that discussion after the class, okay? Because there are people who would there are people who would not understand maps. Okay, I guess it's good to take it after the class. Okay, yeah, let's move on then very quickly. So now let's do some theory. Time for some theory. So we want to, so we have so far looked at comparison based sorting algorithms. So at a very high level, what they do is basically you have a sequence that you want to sort and you put the elements in correct order by comparing elements, right? And you had a notion of a less than, which you defined. If you you have a notion of a comparison and you compare elements and then you reorder them. So this is what we have been talking about so far. There are a class of algorithms which are not really comparison based. So they don't really compare the elements as such, like and still are able to sort the array. And the motivation behind looking for such kinds of algorithms, I will tell you a very, very, very brief history, because I guess history is boring. But yes, in comparison based sorting algorithms, the theoretical lower bound for sorting is n log n. So you cannot do better than this. And this can actually be proved that there will be at least n log n comparisons in any sorting, any comparison based sorting algorithm to sort the array, to sort a sequence. So you can't do better than this. This proof you can search, we can take it up later, but that's not very important. Yes, count sort is here, non-comparison. It's not comparison based. So from here, people started thinking that, okay, the lower bound to comparison based sorting algorithms is n log n, but I am looking for better algorithms. So let's just move to another paradigm or another class of, let's try non-comparison based sorting algorithms. Can I sort the array or a sequence without even comparing the elements? And then maybe I will be able to get a better running time than n log n. And that's basically the motivation behind why the research on this field started. And one such prime algorithm, which I guess all of you are aware of, is counting sort, which is a non-comparison based sorting algorithm. Today, we will talk about two more sorting algorithms, radix sort and bucket sort. So let's quickly dive into the details of radix sort. So far, so clear, right? Only theory? Theory is boring. So radix sort is nothing, but basically people say that, okay, now you have a sequence of numbers. Let's say you have 73, you have 273, you have 45, let's say you have 1652, and you want to sort this. So radix sort is basically telling you that what you can do is, you will get the intuition if I tell you the algorithm. What radix sort tells you is, in the first pass, what you do is, not really the first pass, take out the largest digit, largest element, and count the number of digits of this element. So we will basically be sorting digit wise. So we will first put, so this algorithm will have number of passes, which is equal to the number of digits of the maximum number. So let's say this is n. So this algorithm will have n passes. And in each pass, you will sort on the basis of a digit. So in pass 1, you will sort on the basis of the units place. Then in the second pass, you will sort on the basis of tens place. So this is units place for people who forgot. This is tens place, this is hundreds place, and this is thousands place. In the third pass, you will sort on the basis of hundreds And in the fourth pass, you will sort on the basis of thousands. So that's basically the algorithm. So what this algorithm will do is it will look at all the digits of in the first pass. It will look at all the least significant bits, which is basically the units place. And then it will sort on the basis of their phase values. So this is a phase value. So here it will put 1652 first because 2 is less than 3 and 5. Then it will put 73. Then it will put 273 and then it will put 45. That's the first pass. In the second pass, what it will do is it will switch to the hundreds place, which is this. So now in the hundreds place, what it will do, it will take this as the input and it will sort this. So how will it sort? 5, 7, 7, 4. 4 is the least. So it will put 45 first, then it will put 1652, then it will put 73, and then it will put 273. Now in the third pass, it will take this as the input and sort this on the hundreds place. So you have a 0 here, you have a 0 here, you have a 2 here. So it will put 45 first because it's a 0. It will put 73. It will put 273 and then it will put 1652. And in the fourth pass, it will sort on the basis of the last place. So these are zeros here. So it will put 45 first, then 73, then 273, then 1652. And that's it. That's basically the algorithm for radix sort. Radix is nothing but a digit. First of all, do you get this algorithm? Everyone, do you get the intuition, right? Like how it works and why it works? So here, if you see, we have not really done any comparison. No comparisons have been done and we are still able to sort it.
Sir, this can be implemented in the opposite direction as well, right? The left to right.
What do you think? What do people think? Can we do it in the opposite direction? Yes, it cannot be done in the opposite direction. Why? It's a very simple example, right? Devang, you see, if you take 42, let's yeah, it's the same digits basically. Let's keep two numbers with the same units digit. Can you give a counter? Like I'm still thinking of a counter.
Sir, I mean, if we sort it from left to right, we'll have to
any number.
Remove elements from the bottom.
If you take 42, 39, this will not work, right? Any number you take. Because first you are sorting on the basis of this, then but the next time you will reverse it again, right? So you will put 42 again first because this is less than this.
Oh, but if 42, got it, sir.
Yeah. So yeah, it can only work in the other direction. Clear to everyone? So how do we implement this is the next question, and then we will talk about the running time. If it is not clear, please speak up. I will start taking names in some time. But yes. So how do we implement this? So if you see, this can be implemented using a modification of count sort. So you will have, obviously you will have k passes where k is basically the number of digits. In every pass, what you can do is you can iterate over the array. This array is modified every time. You can iterate over the array. You can extract the ith digit from the, if the digits are same, then you keep the order, whatever is the order in the array. And that's important actually. So now if you, in the ith pass, what you can do is, if you see every digit is in the range 0 to 10, correct? So when you are sorting on the basis of a digit, can you use counting sort? Right? So if you use counting sort, what will be the running time if you're sorting on the basis of a digit and you're using counting sort? Order n. So this will be per digit. order n, right? And this will be for k times, which for us, if we are using integers, base 10. So order n into k, where k is almost a constant, like k is, right? K is 10 for us if we are doing decimals. If we are doing binaries, it will be 2. If we are doing hexadecimal, it will be 16. Correct? So isn't it like order n? This will be order n into k plus n for counting. This is fine, right? Right? Do you understand the running time? N into k? Should I code it or you guys can code it? If you know counting sort. If you want me to code it, I can code it.
Sir, could you just go over it again? My audio glitch. Just as this new array part where we're storing.
So I'm just saying that you are doing k passes, right? And in every pass, you are sorting on the basis of one digit. And you know,
Yes, sir.
So this digit, you know the range of this digit, right? It will be from 0 to 9.
Right.
So to sort this array on the basis of one digit, can you use counting sort?
Yes.
Right? So it will be order n then per pass. And there will be k passes, where k is the number of digits.
Okay.
Yeah, the number of digits in the largest number.
Sir, so the advantage of radix sort over counting sort will be use of less memory, maybe.
Use of less memory. Yes, n into k plus n. But n into k is obviously more than n if k is greater than 1. Yeah, k need not be 10. You are right, Utsav. You can choose any base and sort, basically. That's the generalized version of radix sort. Is that what you're trying to say? Can you unmute? Okay, then let's take it up later.
Sir, excuse me.
Sir, I believe what he means to say is that sir, even if it is not in decimal representation, so the initial example which we saw, the k was 4, right? Even if it was in decimal. So maybe he's pointing out that thing.
Yeah, k is 10, Utsav. K will be 10 or k will be the number of digits of the largest? Tell me this.
Sir, k will be number of digits in largest number.
Right. It will be that?
Yes, sir.
Yes. K will be the number of digits in the largest number. The exact running time will then be order n into k plus 10. Do you get this, what I wrote? This is basically the base.
Sir, can you explain the time complexity part again?
Yes, I can explain. So I will just give you a skeleton. See, what we are doing is we have a for loop, which we are iterating over every base, every digit, every place. Let's say for place I. So I basically for place I from 1 to. Yes, that's right. Log of n, a log of max element. So this is nothing but log of max element is basically the total number of digits in the maximum element. In this, what we are doing is we are calling a sort, which is basically C sort, let's say, on the basis of this I, correct? We are sorting that sequence. That's the algorithm. How are we implementing this C sort? If you see, we will take an array of size 10. So we will implement using counting sort, correct? So we will take an array of size 10 and we will take every element and we will count on the basis of this place I. So array 0, if you take 365 and you're counting on the basis of this digit, then the sixth place will increment, the count will increment by 1. Then you have 125, then in the second place, let's say this is 2, the count will increment by 1, and so on. So once you have the counts, then you can either create a new array, or if you want to do it in place, you can do it in place also. You can arrange these elements, correct? So what is the total running time of this? This is order 10 plus n, right? And what is the total running time of this? How many times is this being called? This is being called, this is what we said to be k. So this is called k times. So it will be 10 plus k n into k. This is the total running time of radix sort. Did I do any mistake here? Is this right? In the radix sort, did I do any mistake? Or this is right? This is base. Yeah, you can do base.
So how is 10 getting added there?
In this C sort, if you see, there are two passes, right? In the first pass, I am constructing this array. So that will take 10 operations, right? I am looping 10 times. Is it 10 or is it? So when I'm constructing this array, how much time am I taking? I'm taking n time, right?
Yeah.
I'm taking n time when I'm constructing this array. And then what I'm doing is I'm looping over this array.
Okay, got it.
So this takes 10 time.
Got it.
And this takes n time. And I will put it again, which is again n. I will put it here only. This algorithm.
Yeah, got it.
Right? You want, how many of you want, quickly, can I ask for people who want me to show the code? Quickly. Okay, I see yes, a lot of yeses. Let's code it then. For people, okay, for people who actually don't want to see the code, I can give you a question. Do that. I mean, you will not be able to do that, but yeah, do that. Try this for people who are not interested in seeing the code. And this is like a chocolate question. So if you are able to do this, I will ship a silk or to your house. If you have not done it before and you're doing it and you are able to do it. Okay. All right. Let's code it then. Let me just open up my editor. So this, my atom screen, everyone is able to see. Right? You are able to see my terminal, my editor. I'll just clear up my office work here. So office work cleared. Now time for this code. So let's say this algorithm is int of, let's say, radix sort. Not int, let me just say that I can return. So here if I take a, let's do vectors only so that people are able to follow. It's two vectors. You want to sort this, correct? So first what I will do is I will extract the number of digits of the largest number, right? Because that is the number of times I'll be running this algorithm. Ashish, you're talking about the question that I gave you. But then you will not get a silk, maybe a 5-star. I mean, yeah, if you even if you are able to come up with an approach, it's good. Yeah. Okay, so I will just extract the number of digits of the largest number. How do I do that? This is easy peasy. Meet, if you want to do it with custom comparator, then basically that will be again n log n, right? So let's do a count sort thing. And maybe we can do your algorithm offline. So let's just count the max number. I'm also thinking on the go as I'm writing. So this is the max number. How do I count the number of digits? All of you know. This is now I will do a I will run this k times. I will call C sort, which is let's say or let's call it a radix sort helper, which I will pass this array and I will pass the phase value or place value which I want. All good so far? Any issues? Any? हाँ नाइव इम्प्लीमेंट नहीं नाइव इम्प्लीमेंटेशन ऑर्डर एन में करना है. Yeah, do it in order n. अरे सारा ही एक्सेप्ट होता है उसमें. It's not naive. Yeah, order n or naive is not order n, right? N log n, right? naive मतलब सॉर्ट करो और डिफरेंस लेते जाओ कंसेक्यूटिव नंबर्स का और मैक्सिमाइज कर दो उसको. Till here everything is fine for people who are following this code. Right? Now I will do radix sort helper int I. Now what do I do is, okay, let me create a count array of size 10. I don't like arrays, I like vectors. So let me create a vector. Initialize to 10. So now understand, this is nothing but counting sort. So people, Hiten, you had questions in counting sort, right? So just follow along closely. You will be able to understand what I will do here. So in the first pass, I will just increment the counts going over all the elements of the array. So I will go over the elements of the array and I will increment my count of, now this is something that you need to write. Okay, let's see, this is array by I mod array by I is right, array by I mod 10. Is this right?
It should be array of I, right? Like array is
array of j. Yeah, is it right? Is there anyone who understood this?
why can't we just write array of I? Like
Array
we
of
have
I.
to increment the
Array of I.
what is I? I is the position of the numbers, right?
I is the digit, yes. I'm in the digit position.
Digit, and we have to update the digit. Or that what do
Yes.
we have to update in count? We have to update the actual digit, right?
We have to update how many times that digit occurs.
So I is, so how is this giving us the digit?
When I is 1, you're talking about the units place. This is basic number system. What you will do, see, when you are at units place, how do you get the units place? How do you get the units place of a number n? You say n mod 10, correct? How do you get the tens place of a number n? You say n by 10. So n by 10 will basically give you the tens place mod 10. Right? This is, I'm just writing n by 1.
Got it. I got confused. Like I thought I was the number, but it is the index. Okay.
Yeah. So let's say for 5, 6, 8, 9, n by 10 will be 568 and modulo 10 will be 8. This is number system, right? Anyone else for whom I need to explain this? What I did here? Right? Everyone got it? Shall I move ahead? Should I take names? Because I'm getting less hacks. Akash, do you understand? Are you in the class? Abhinav, do you understand? Slok, Sahana, Tanvi, Utsav, I'm just picking up names. Mitali, Ishan Khare, Harika. All right. So now let's see. Once you have this count, this is nothing but I'm just doing a counting sort implementation, by the way. So follow along if you don't know the implementation of counting sort. I will shift. Now this is a neat trick that I do. Shouldn't it be array j by power 10 I minus 1? You are right. So here I can do start from 0, or I can start from 1, it doesn't matter, and place value is 1. Correct? Is this fine now? Fine. Meet, is it fine? Or is it still wrong? Right. Others, I'm just passing 10 or 100. All right. Yeah. Now let's go here. Yeah. Okay. Now I will shift. So this is a neat trick that we do in the counting sort algorithm, wherein what we do is we shift the numbers. So for that, what I do is I can go over this from 1 to 10. Now just see what I will do here. Count I will simply through this, basically what I am able to do is that, I mean, just think about it. What have I achieved by doing this? Can anyone tell me? Yes, I have added the previous element. So what have I achieved? I have achieved for a particular digit, I have achieved the last position of the array where I need to put it, like last position -1. Right? I will repeat that. For a particular digit, for a particular number, I have found out for a particular digit the position in the actual array where I have to put it, the last position. So what I mean by that is, see this picture. So through this, what I'm trying to do is, I have a count array, correct? And I have some counts, 3, now I'm 2, let's say 1 and 6. Now if I accumulate this, what it come down to? 3, 5, 6, 12, correct? My array is of size 12, 0 to 12. So now what I'm saying is that there are 3 numbers here, right? In this, I am saying that this basically represents the last index. I mean, -1. This -1 represents the last index where I can put this number. This represents, so here you have 2 numbers. So this represents this index. So this is basically this set. This is basically this set. There will be 1, 6. This will basically represent this. Right? Do you get it? Like the idea?
So like all those numbers which have the same element in that particular like place value will be placed in the numbers which will be in their in the cumulative sum.
It will be placed starting from this index. Yeah, starting from this index -1 to this index. So if you have numbers which are in this, you have one number here. So it will be placed starting from this index -1, which is 5, till here, which is 5. So it will just be placed in the 5th place. Here you have 6 numbers. So you will start from 11. In the 11th place, you will put the first one. In the 10th place, you can put the second, till the 6th place, where you will put the last one.
We'll do that in the opposite order.
Yes, we will do that in the opposite order in the code now. Is this clear? What I did? I'm not creating another array. I will just do it in place. Let's complete the code and then you can ask more questions. So now what I will do? I can simply go from the last number to the first. I can find the position of this number in the count array. How do I do that? Count array. Why am I doing I here? Nobody told me. This is J. Let's keep this I. Let's rename this to place value. So this upon place value mod 10. This is the right. So I will put this and you can do it downwards here if you are really energy. In this result, this -1, can I put array I, and then can I just decrement this? Will my res array will have the sorted one, sorted sequence? हाँ यहाँ I -- होगा, ठीक है. Did anyone get these two lines? Think. I told you, right? This number is representing the last index. I mean, this -1, this entire thing is representing the last index where you can put those sets of elements. I am just putting it and I am decrementing it by 1. Take some time, it's fine. Now I will just copy result to here. That is simple. And that, ladies and gentlemen, is the entire radix sort. I had never even in my life dreamt that one day I will be coding radix sort. But yes, today I have done it. Good, all good. Any issues in any part? जे कहाँ यूज किया यार? जे किया ही नहीं. अच्छा यहाँ कर दिया क्या? अरे जे भी कर लो यार डिक्लेयर. या इसको आई कर दो, ठीक है. Right? So now you can see the, yeah, this is not in place. You're right, Bernie. That was my mistake. I can share this code with you. That should be fine. क्या place value declared नहीं है? कहाँ पर declared नहीं है भाई? अच्छा यहाँ पर. यहाँ कर देते हैं declare. Cool. Shall we move ahead? So now you see the running time will be clear, right? N, 10, N. So N plus 10 here, and how many times? K times, which we were saying. If you don't want to count this, you can simply do a log here also, if you want.
Sir, I didn't get the second line in the last loop. This count array I by place value. This one, yes, this one.
This one?
Why did you do this? Yeah.
I'm just updating the next place where I can put an element from this bucket. So the first time when I put an element from this bucket in the actual array or in the resulting array, I can put it in this index. Yes. Do you understand this?
Yeah.
So now I'm just updating it so that I can put the next element. Cool. Can I have X? Maybe real X? Hopefully. So that was radix sort for you. There might still be bugs in the code, but yeah, at a very high level, I guess you get the idea. Yeah. Any questions? Are you following? Atul, all good? Yes. Okay. So that's basically radix sort. Convert all numbers to hex and then do radix sort. Check for maximum strength. Oh, for the question. We'll come to the question. Yeah, I will give you the code, Ritik. I will share it on Slack. Okay. So let's look at the last type of algorithm without any more delays, which is basically bucket sort. So I guess all of you know bucket sort, but so the basic idea behind bucket sort is that you have an array of numbers. So this is mostly useful when the input is uniformly distributed over a range. So if the input follows a uniform distribution, then this bucket sort is applicable. So what we do in bucket sort is we create, so the range is, let's say min minus, let's say this is the max number, this is the min number. Let's say I want to create B buckets. So what I will do is I will have an array. It's like 0 to B minus 1. These are my buckets. And from 0 to, so max minus min upon B will give me the gap, right? The range. So from 0 to, let's say this I call gap, 0 to gap minus 1, all the numbers will be here. Then again, gap to the next, basically 2 into gap minus 1, the numbers will be here, and so on. So I have just distributed the input. So let's say this was my total input. In the number line, I have distributed it into buckets. So I say all these inputs in this number line will go here. All these inputs will go here. All these inputs will go here. All these inputs will go here. So I'm just bucketing. So if I had 3, 5, 8 here, all of them will go here. 3, 5, 8. And if I have, let's say 9, 11. So these two will go here, 9, 11. And then basically what I'm saying is, once I have this, you can just individually sort them. Sort this individually, sort this, sort all of them individually. And then you can just put them one after the other, put all the buckets, and that will be the sorted array. Did you get it? Like at a very high level, what we are trying to do? Which part,
No, sir.
Ishan, do
Please
you
repeat.
want? So do you understand the bucketing?
Not really, sir.
Not really? Okay. So what I'm doing is I have just think about my input, and let's say on a number line, in a number line, my input is from here to here, min to max. And there are some numbers here. There are some numbers here, there. So what I do is I evenly divide my number line, which is basically the range. What is the range? Range is from min to max, right? What is min? Min is the minimum number in the array. Max is the maximum number in the array. What I do is in this range, I create B buckets. That's it. So what B buckets of equal size. So basically I divide this entire line, number line, into B chunks. So this is the first chunk, first bucket, this is the second bucket, this is the third bucket, this is the fourth bucket. And any number which is here in this range will go to this bucket. Any number which is here will go to this bucket. So for instance, if I were to take an example, let's say you have 2, 3, 5, 6, 8, 10, 11. Your range is from 2 to 11. Let's say you plan to do a bucket size of, let's do one more element to keep things simple. Let's say 12 or let's say 20. So 11 and then 20. And let's say you plan to make buckets of size 2. Okay. Not really buckets of size 2. You basically, let's say you want to make 4 buckets. So if you want to make 4 buckets, what you do is, this is the entire input. You have 4 buckets here. You will evenly divide the numbers in these buckets. So if you have to divide 4 buckets in this range, what will be the size of each bucket? Do you get my question? 2. So if I have to divide, it will be 20 minus 2 by 4 roughly. So what that means is I have to divide this range. What is this? This has 16, this has 18 numbers, right? This has 18 numbers, correct? 18 numbers as in from 2 to 20, how many numbers are there? This has 19 numbers. And I have to divide this uniformly into 4 buckets. Let's take a multiple of 2 to make things easy. 21, correct? So this will basically have 20 numbers, and I want to divide it into 4 buckets. So the first bucket will have a range 2 to, so 20 numbers 5. So 2 to 6 will be one range. So this is nothing but 2 to 2 plus, this was 5, right? 5 is the range. So 2 to 5 minus 1. Then from 7 to another 5, 12 or 11. And then 12 to 16. And then 17 to 21. So all the numbers in this range I will put here in square brackets, both included. So I will put 2 here and I will put 3 here. 5 I will put here. 6 I will put here. 7 to 11 I will put in this bucket. So 8 I will put here. 10 I will put here. 12 to 16 I will put in this bucket. So 7 to 11, 11 also I will put here. 12 to 16 I don't have anything, so this will be null. And this I will put the remaining 21, which is basically the 4th range, 17 to 21. So I evenly divide the range of numbers into equal sized buckets, and then I distribute my elements of the array accordingly. So this is how I construct the bucket. Now ask me if there is a question in the construction of the bucket. Do you understand?
Yes, sir.
People, all of you who said 2, do you understand this now? Correct. So now then what I will do is I can sort each of them individually. So I will sort 2, 3, 5, 6. And I will sort 8, 10, 11. And then I can just put them one after the other. Correct. That will be so these individual buckets I can sort using any comparison based sorting algorithm. So the benefit
so so basically it will be shorter because it compares less numbers at a time.
Let's debate on the running time. So what will be the running time of this? See, bucket construction will take order n time, which is basically, let's say there are n numbers. So bucket construction will take order n time. After that, when you are sorting, you can assume a bucket size. So if the input is uniformly distributed, you can assume some input size, right? So if the bucket is uniformly distributed and there are, if the input is uniformly distributed and there are b buckets, so then n by b will be the size of every bucket, correct? So if you are sorting by any comparison based bucket, this will be n by b log n by b. And this you are doing b times. So this will be the complexity of sorting all these individually. And then you will put each of them one after the other, which will take another n time. So what is the complexity? Is this right, what I wrote? So this is n log n by b. So we assume that because the input is uniformly distributed, I mean, you can do counting sort. I'm not saying you cannot do counting. So this is here. I mean, you can have issues, right, Dhanil, with that, because let's say you have the range is from 1 to 10 to the power 9. You cannot do counting sort on that, right? You cannot create 10 to the power 9 buckets or an array of size 10 to the power 9 and count. Correct. But even if you have an input of this range 1 to 10 to the power 9, you can do bucket sort, because that is basically some bucket number of buckets.
Sir, putting each element into a bucket, wouldn't it require log of b time? So for n elements to put into bucket, wouldn't it require n log b time?
For putting elements, you are saying it will require n log b. Why? Every putting is a constant, right? Putting will take n time, right? Determining the bucket where you have to put is order 1, and then appending is order 1.
Sir, how do we determine the bucket in order 1?
That is, you can do whatever number you have. I mean, let's say this number is I. You can determine the bucket by I minus min. How do you determine the bucket? I think you can determine it, right? I mean, so think about the mathematical formula. I can still, like, I will have to think, but you can determine in order 1, like the bucket number to which you have to put a particular number, right? That's not, this is order 1 for sure. I mean, we can discuss this later on, but like how to find this, but I will also have to like think. Okay, Ishan, is that cool? So think about how you can find the bucket number. What you have is you have the number of buckets. You can use that to find the bucket number to which this will go. You have the number of buckets and you have n, and you have the current number I. Using this, you can write a formula to know the exact bucket number to which this number will go, the ith number will go. Complexity, Swami, is, I'm assuming that if you have b buckets and input, you have n inputs, and if each input is if the input is uniformly distributed, you have n by b bucket. You have every bucket has n by b elements, right? That is fine. So then how much time will a comparison based algorithm take to sort n by b log n by b? Correct? And you have to do it for b buckets. So b into this. So this is the running time. Bucket number is array I minus minimum by b. Yes. Yeah. Something like a floor of that or the seal of that.
Sir, as the bucket size is, we can assume the bucket size to be less compared to the overall width of the array. So can't we apply some simpler sort like counting sort on the bucket so we get a better time complexity?
So you're saying if we apply, come again, you're saying if we have bucket sizes are like much less than the size of the array. Okay.
Yes, sir. Let's say if array limit is 10 raised to power 9, but if we distribute it into 1000 or 10,000 buckets, so each of those buckets will be 10 raised to power 5, and then on each of those bucket, if we can apply counting sort in order to reduce our time complexity, right?
So you are just optimizing this step, right? You're saying, can I do this with counting sort? Yeah.
Yes, sir. Yes, sir.
Yeah. Makes sense. You can do that if that range is within permissible limits. I was just talking generally. Yeah, that's also a good suggestion. That's a good idea actually. Yeah. Any questions? Please ask. I know this gets a little messy, but you can ask. Is it clear to everyone? Clear to everyone? Is it? Are you alive? Are you there? Have you slept off? Anyone to which it is not clear, please let me know. So this is basically bucket sort, and you understand why we do this. This gives us n by b, we assume, yeah, Meet.
Sir, is there any optimum method to choose the
The
number of?
number of buckets? I think so, but you can, I think so. Find out about it. Like, I don't have it at the top of my mind, but I think so there is an optimum number. I mean, there are white papers which talk about this, finding the optimum number of buckets. I remember reading one when I was in college, but I'm not able to recall as of now. Not clear, but we'll do my, okay. Anyone else? If you have any specific questions, you can ask Hiten. Otherwise, it's fine. Yeah. I mean, unless you do it, obviously it won't become clear. So let's do the question of the day. Then the question that I have been waiting for. And this will be interesting. Let me pull out the question. ये क्वेश्चन तक तो सब मर जाएंगे. Similar to square root decomposition. Square root decomposition, yes, I think. Yeah. Convert all numbers to hexadecimal. Acha, your mic is not working. And then do radix sort. Okay. And check for max difference. Max digits can be 8. So you want to convert it to hexadecimal, then do a radix sort. What's the time? This question discussion will take about at least 30 minutes, I can say. I mean, if so, I guess we will have to do it tomorrow, Chirag. Yeah, you will be dead, definitely dead after this question. You will do a radix sort, Utsav, okay. Why are you converting to hexadecimal? Like, what is the intuition behind that? To reduce the number of digits. But okay. Yeah, conversion will obviously not be constant time. That's also a good point. Can we use a bucketing algorithm for this? This will be interesting. So people who are asleep, please wake up. Hex has 16 digits. Hex has 16 is the base. So you have alphabets from 0 to E. What do you mean hex has 16 digits? Yes, that is the base. That's what we call the base. So the alphabet size is 16. Any suggestions? Okay, let's think along. Okay, Utsav, let's discuss your algorithm after the class. Is that fine? Yeah, because there are 60 more people waiting. Okay, let's discuss. I will give you 2 ideas. Okay, let's discuss, and even if when we are discussing, someone is able to tell me an algorithm, we will have a chocolate for him. Okay. Fine tune it, Dhanil. You are there in the direction. My first idea is that I don't want to do n comparisons. first and last bucket. No, what is bucket size? There are a lot of things that you need to figure out. It's not you can know what is the bucket size. It's not necessary that they're consecutive. That's also a point. Okay, let's see. I will give you two ideas. My first idea is that I want to obviously put elements into buckets. All the elements of my array. This is the array.
Sir, if we use counting sort on this,
what is the range of numbers? 32-bit.
It won't be possible. No?
2 to the power 32, which is 10 to the power 9. Right? You cannot create an array of size 10 to the power 9.
Right.
So first thing is, obviously I want to put my elements in buckets. Okay. I want to put these elements in this bucket in such a way that the maximum difference that we are looking for in the question is only across the bucket. So it will not be between two elements inside the bucket. It will only be between the buckets. It will be from one element from this bucket and an element from this bucket. That's the first idea. So first of all, do you get this? What I'm trying to say? There are a lot of numbers. Okay. I want to put them in buckets in such a way that the answer that I'm looking for, I don't want it to be between two numbers in the same bucket. I want it to be between a number from a bucket, from one bucket, and another number from another bucket. The maximum difference. These differences I can skip. Can I calculate a bucket size in this manner? Can I have a bucket size in such a way that I can guarantee that this type of a comparison, this type of a difference will be the only way we can get, the answer will only be present amongst these and not amongst these. First of all, is this idea clear what I'm trying to say? Can I come at a bucket size? Minimum of first bucket, maximum of second bucket. Yes, that's what we will do. So Gidans has made it even a little more precise. He's saying that more precisely what we want to compare is we want to compare the maximum of this bucket and the minimum of this bucket. That's it. And then again a maximum of this bucket and minimum of this bucket. Only these comparisons I will do, and I will be able, and I take the maximum of all these differences. That will be the answer. I don't want to do comparisons within the set. So can I arrive at such a bucket size? This is first Q. And this is probably the crux. Max minus min by size of array. Why is that, Mithali? Yeah, bucket size should be smaller than the max gap. That's a good point. So let's build this incrementally. So if you want to create this bucket size, what kind of a bucket size we need? We need a bucket size which is less than the max gap, correct? Can I put a lower bound on the max gap? That my max gap will always be greater than a particular quantity. Then if I take a bucket size which is of this size, I mean less than this, then do you follow that I can guarantee this? Do you follow what I did here? I can repeat. So what I'm saying is, can I come up with a lower bound on a max gap? The answer basically, can I can I bound it by some quantity? So I on a lower bound. So can I say that the maximum gap, the answer that we are looking for, no matter what, will always be greater than this quantity t. And once we know that this is t, maximum gap is somewhere here. Once we know, then if I create a bucket size which is here in this array, let's say this is the bucket size that I create, then I am safe. Then I can guarantee that. Do you follow this? Anyone follows this? Akash, what part do you not follow? Do you understand this idea that I want to only compare across the buckets and not within the bucket? Then the next part is basically I'm saying that can I find the maximum gap? That is the answer that I'm looking for. If I, let's say if I have a lower bound, somehow by God's grace, somebody told me the lower bound, and he or she told me that this is a guarantee. Whatever answer you look for, no matter what the array, no matter what, this is the lower bound for that. Then if I have that, then I can choose a bucket size which is less than t, right? And I will have this property. That's what I've said. So then the next step is, can I calculate this t? A couple of people have already done that, but yes. Mitali, can you unmute and say what was the logic you used to arrive at that number? I mean, that formula. Meet.
Sir, what I did was, sir, if there are two numbers, let's say, so there will be only one gap between them. So considering that pattern, we need to divide it by n-1 numbers. So that is from where I got the denominator. And the numerator I got by considering the maximum and the minimum element. So the difference between them will be max minus min plus 1.
Mm-hmm.
So if we divide, then basically Utsav has written that average of all gaps. So that is what we are basically calculating, that if we calculate the average of all gaps, so there might be two cases, that all the gaps be equal, or the case in which at least one of the gap will be greater than the average of all the gaps.
Mm-hmm.
So if we consider this pattern, and so there will be at least one gap that will be greater than the gap that which we have considered, and then it will satisfy our criteria.
Mm-hmm. Yeah, that's also one way of thinking. For others, let's do it. I will tell you, let's assume the case when we have the numbers evenly spaced out. So let's say you have an input array where you have this kind of an arrangement. So these are the numbers in your array where the spacing is 3, equidistant. So here your answer is 3, right? Correct? Now, what is this gap? How do you calculate this gap? If I want to calculate this gap, let's look at this gap. This gap is nothing but you have 18, you have 3. So this is basically the total spectrum, the range, and you have n-1 gaps, correct? If you have n numbers, so here you have 6 numbers. You have 5 gaps, gap number 1, gap number 2, 3, 4, 5. So n-1, which is 6 minus 1. This is the size of one gap, correct? G, right? So G is basically max minus min by n-1. right? Do you follow this? I just calculated the gap size for this kind of a distribution where the input, the array is in such a way that all the elements are equidistant from each other, like consecutive elements are equidistant. So then this is the gap. And this is also the answer, right? Clear? Are you with me or have you lost me? So now I tell you that this is the minimum. Now my claim is that this G is the minimum, is the lower bound that we were seeking. And the proof to this is very simple. The proof is very simple. You just try to alter any number, try to shift it either left or right. Your answer will increase, right? So if you move this number from 15 to 13, this will be the answer, which will be more than G. Correct? So any sequence you get as a question, you can obtain from this configuration, right? You start with this configuration and then start shifting the numbers. So that total will be obviously greater equals G, right? The answer for this. Do you get this, what I said? Everyone? Anyone who wants me to repeat this? So this is basically the lower bound then, if you understand this. So now if this is the lower bound, then my algorithm is very simple. Then I simply say that this is the bucket size, max minus min upon n minus 1. Let's call this B, which is nothing but the bucket size. So I want to have this as the bucket size. And now what I want to do is so then the algorithm is very simple. I simply take elements, I create suitable number of buckets, and I will simply put these numbers. So every number I can start putting in the buckets, correct? And every time when I'm putting, I will take the minimum. I will keep a min and the max, a running min and max of whatever elements have already been put in the bucket, and I can update that min and max. That will be the first pass. And in the second pass, I can simply take the difference between min and max of consecutive buckets. And that's basically the answer. Do you follow? I can repeat as many times as you want me to. We will code it, but first let me know if the algorithm is not clear. Which part, Abhinav, do you want me to repeat? Do you understand the lower bound?
Yes, sir, I understand. But how did you like 0 and then 0 is being placed? That array part is not clear.
How we put elements in the bucket, right? That we will see.
Okay.
That we will see in the code, yeah.
So why are we comparing only consecutive buckets? Like even the minimum and maximum can be adjacent to each other, right?
No, this is the range, right? You have min and max. You have divided all the possible integers between min and max in these buckets. So you cannot compare this versus like an element from this range versus with an element from this range, right? It's not consecutive in the actual array. If there is a bucket in between, if there is a non-empty bucket in between. Right?
So for empty bucket, we need to take care of that case, right?
Yeah, you need to take care of empty buckets. I mean, you can keep a Boolean. Lower bound, I can repeat. So which part do you not understand in the lower bound? Do you understand that? So how we put elements in the bucket, you will understand when we see the code. but it's basically the same thing as bucket sort. You have a range from min to max, and I have divided it into buckets of size b. So all the elements which are here, this is again b. So all the elements which are here will go into this bucket. All the elements which are here will go into this bucket. So the bucket size is not really, if the bucket size is b, that does not mean that you will put b numbers in that bucket. That's one fallacy. If the bucket size is b, it basically means that it basically means this in pictorially in the number line. And so it can contain any number of numbers, any number, at most b numbers from the array. Right? For instance, what I want to say is, if you have 5, 8, 9, 15, and if your bucket size is 3, so let's say your one bucket is from 5 to 7, and then your next bucket is from 8 to 10, bucket size of 3. Okay. So then basically 5 will go in this bucket, 8 and 9 will go in this bucket, 15 will go in the fourth bucket. So that's basically what bucketing is.
So can you do an unsorted array?
Can we do an unsorted? We will not sort it at any point.
I'm saying, can you do a dry run on 5, 15, 8, and 9?
You will have to find the bucket number for that, which I can tell you. You want to do a dry run on, give me the numbers 5, 15, 8, and 9. And
yes.
Okay, so what is the min and the max? 8 and 15. Okay, so let's do a bucket size. Max minus min by n minus 1. This is the bucket size. This is basically 15 minus 5 upon 4, 3. So this is 10 by 3, 3. I will take the floor of that. So 3. So bucket size is 3. So basically what we are doing is, let's just enumerate all the numbers. So this is 5. Okay, this picture might make it more clear. So you have a number line 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. This is the number line. And my first bucket is from 5 to 7. So this will be my first bucket. Second bucket is from 8 to 10. 11 to 13 is my third bucket. And my fourth bucket is 14 and 15. So now I will go through the elements. 5 falls in this range. So 5 I will put here. 15 I will put here. 8 I will put here. 9 I will put here. This will be the bucketing. Actually, I will not put the buckets. What I will do is, for every bucket, I will keep a min so far and a max so far. And I will keep updating that, nothing else. I don't need all the elements of the bucket, right? I only need the minimum and the maximum. So in one pass, when I'm scanning from left to right, I will update the min and the max. So here the min and max both will become 5 in the first pass. After that, I will move to 15. Here also min and max are both 0. I mean int max and int min. So this becomes 15. Then I have 8. 8 here it will become both will become 8. Then I have 9. So I will compare it. This remains 8. This will become 9. So this will be my configuration, and this is null. I will have to store a null also somehow. So now after that, this is pass 1 where I have constructed the bucket. Pass 2, I will go over this and I will take max minus min. So max minus min, 8 minus 3, 3. Then here max minus min, this is null. So I don't do this. I skip this bucket basically and I come here. which is 9 minus 15. 15 minus 9, so it is 6. And I will take the max of all these. So this will be 6. So 6 will be the answer.
Sir, what happens if the bucket size is 0?
What happens if the bucket size is 0, which means that you just have one number? We will keep at least one bucket size of 1.
Sir, not just one number. If say the numbers are
all the same,
not even the same. If the numbers are 8989, let's say.
Okay. No, so we will keep a bucket. So we will take this. Yeah, you are right. We will take maximum of this comma 1 always.
Okay, sir, got it.
Right.
So why can't we use counting? We can use counting sort for this, right?
Counting sort is 2 to the power 32. The range is the of the numbers.
Okay.
We are kind of finding expected positions in sorted order without actually sorting it. I mean, yeah, however you want to interpret it, expected positions in the sorted order. I'm just keeping the maximum, yeah, then the minimum, just 2 numbers, expected positions of the 2 numbers. Like the actual position, you should say, not expected. Is this algorithm clear?
So, sir, the worst case is that we'll end up creating each bucket for one element.
Yes. And then basically it will come to, what will be the running time then? N.
Yeah.
Is that the worst case? If you have bigger buckets, then you are better. Is it always?
We are maintaining max and minimum for all the bucket size, so it's always N, I think. Iteratively we are doing.
Yes. हाँ तो आ गया ना समझ में. Now, yeah, you're right. So now I can take questions on people who do not understand this, and then we will code it.
Sir, actually, we also need to take care of the case when all the elements are equal, right?
If all the elements are equal.
Sir, because all of them will fall in the same bucket.
Right. And my max will be initialized to 0. I mean the difference. It will, then you will have one bucket, right? So
yes,
that is,
yes.
So it, I mean, that basically depends on the initial value that you give here.
Okay.
Sir, if all the elements are same, then when calculating the lower bound, if lower bound equals to 0, then we can just return 0, right?
If, come again, if all the elements are same?
So while calculating the lower bound, while doing max minus min by n minus 1, if that is 0, we can just return 0, right?
Yeah, that also you can do, correct.
Sir, we cannot return actually.
We
because
cannot return?
Sir, because in 8899, which we saw, the actual answer is 1.
See, he is right, yeah. In 8, if this number is the counter basically to your question.
I mean, if we do max minus min, if max minus min is 0, we can return 0, right? For all the same elements.
So you're saying max minus min. Yeah. If max minus min is 0, then all the numbers are same. You can either handle it up front or you can handle it here. It's fine. Yeah. Any more edge cases other than these two? Right. Do you understand? Can I have one set of acknowledgements from whoever is alive? Do you understand the lower bound? How we constructed it? Anyone needing any clarity on the lower bound?
Sir, will we be able to do these type of questions after only solving them once? Like if the same question comes in an interview, I'm not sure will I be able to do this again. So what's the solution for that? I understood everything, but
Yeah,
The thing
so
that
I
yeah,
will tell you. So if an interviewer asks this type of question, the intention behind that is not, he's not expecting the right answer from you in one go. So the idea is that he wants to check your, how well you are able to navigate a question and what is your, so that's basically what problem solving is, right? He will give you hints. He's not expecting you to solve this all at one go, and as soon as he blurts out the question, he's not expecting you to write everything in and solve it. He will basically guide you. So he will maybe tell you what I told you, that let's talk about this thing, that can we come up with a lower bound. Can first he will tell you the idea. Okay, let's say we want to do bucketing. Can we do bucketing? Then maybe you might say, yes sir, we can do bucketing, but then we will have to, he will tell you, let's say we want to do bucketing and we only want to compare across buckets. So let's try to find a lower bound. So that's basically, that will take up 10-15 minutes, wherein you are also thinking, and he's helping you find out the lower bound. So there he will maybe point you at, think about the case when you have a uniform distribution or all the elements, consecutive elements are evenly spaced. So then you will say, okay, for this the gap is this. So then he might guide you. So what can you conclude about the lower bound from this? Then you might say that, yeah, from this I can say that this is the lower bound, because any other configuration I can come to this configuration from that configuration by moving elements left and right. And then from there you can basically come to this. And so it's incremental in the interview. It's not Boolean. No interview is binary.
okay, so we won't be given these questions in the coding round, right?
Mostly no.
This type of questions.
Mostly no. I mean, if they give, it will be done. It can be done in nlogin also. Like the editors. Okay. First of all, coding rounds, nlogin and n are nearly the same. Like it's very hard to write test cases to differentiate nlogin and n. That's one of the things. So mostly the companies don't take so much effort to design test cases such that your algorithm strictly runs in order n and not in nlogn, so that it gives a TLE on nlogn and a right answer or accepted in order n. That is very rare. You will rarely find questions and test cases or online judges that do that. So a coding round, even if they give it, you can do it in brute force way. It will mostly get accepted. And then in interview, maybe they might follow up saying that, okay, this was the question in the coding round. How did you do it? Then you would say, I did this. Then they might ask, can you do linear? Then you might say this. Yeah, this is how I can do linear and so on.
Okay. Thank you, sir.
Yeah. So interviews are never binary. That's like one tip. Treat your, I mean, easier said than done. I know it's very hard. It's basically a skill that you have to master, but I mean, you have to treat your interviewer as your friend and think like you are having a healthy discussion like you were having with me in this class. It's like that. If you are able to do that in the most polite manner, then mostly you will like ACA every interview. It's never Boolean.
Okay.
Should I quote this? हाँ, HR questions अभी बाद में करते हैं, ठीक है? अभी पहले खत्म करते हैं क्वेश्चन, ठीक है प्रद्युम्न? After that, HR questions. Should I code this? Yeah. Or you want to code it? Let's code this. So this will give you an idea of bucketing also, which we have not really coded. So yeah, let's code this. So let's do this. Let's first, whatever you want to write, whoever is your god. Yeah, Jesus. Okay. Let's find the bucket size. call it B. First find the minimum.
Should we write these comments during competitive programming also? Does it?
I mean, practically no. Ideally yes. Practically it's more I mean, the online tests that you give, they are most like the shortlisting criteria is just the number of test cases that you pass plus your
No,
CG.
does it help in debugging and stuff, like when we are failing some?
You are talking about online interviews, or you're
No,
talking
not
about competitive
interviews.
programming?
Yeah, about
Generally
competitive
contests.
programming generally.
Yeah, I mean, that's very subjective. I would suggest, I generally do it if that algorithm is multi-phased, and if I feel that I might lose track of my own algorithm, if it becomes long and tedious, then yes. But I don't like, it's very, unless you do a very hard question or expert level question, it never becomes so tedious that you forget what you have done in the top.
Okay.
Right? But it's your call. So let's do this. I'm just trying to find the minimum and the maximum. I will do that. Now I have the my bucket size will basically be can I leave it as it is? Or maybe I can do, you can do it here only. Now, once I have the bucket side, can I put them in these buckets? So for this, let's see. Let's create two vectors. In fact, you will have to create three vectors. Max B, size B. Let's initialize everything to min. Create min B. Initialize everything to min max. That should be enough. Now, once I have that, let's bucket. How do I bucket? I will start from 0. Over all the elements one by one. Find out the bucket for this num psi. How do I find out the bucket for num psi? Bucket number will be nothing but whatever the number is minus the minimum upon the, what will be this, this minus this upon, what will be in the denominator for the bucket size? Like the bucket number. Num psi minus minimum number upon B. C log this. राइट ये किसी को समझ आएगा? बकेट नंबर जो भी जिंदा है, अभी लिखेंगे actual. In fact, I'll comment this. So this is basically I am at a particular, so this bucket size, if you have to find out the bucket number. So this is basically what I'm saying is that if you are at a particular number I and every bucket is of size B, which bucket will you put this in? That's what I have to find. So what I do is this is min. So I compute this gap, this distance, which is I minus min. Okay, and that divided by the number of buckets will give me the seal of this, or this basically, if you take an integer division of this plus 1 will basically give you the bucket to which you have to put this, right? Because it's B, and then there will be a point where the new bucket will start. Okay, think it's I mean, unless you think it, you will not get convinced. I can explain that again. So this is the bucket number, but I want the bucket index. So bucket index is bucket number minus 1, correct? So max B of bucket num minus 1 is nothing but max of max B bucket num minus 1, whatever is there, and num size, and copy this, replace this with min, to get the minimum. Is this bucketing clear? And
Sir,
then
what happens when num size is equal to min num? The bucket num comes to 0.
Num size equals to min num. Yeah, you will put it in the first bucket, right? Okay.
So the bucket num is not the index, it's the number, so it should be 1.
Okay, that's the one case. Other than that, every other number is fine, right? You will be able,
as far as I see.
You need a minus 1 here, right? Am I right? Or you don't need a minus 1 here?
We need a minus 1 there for all the cases, but for when num size min num, it will be 0. So you can write an exception for that. For all the other cases, it will work fine as far as I'm seeing.
Yeah. Yeah, let's see. And what?
Sir, can't you do nums of I minus min num plus 1? Then divide by B.
Here you will do a plus 1. And you will get rid of the
so
seal.
So if it is 0 point something something, that seal will be 1.
No, the seal will still be 1 even if you keep this, right? That plus 1 will not really, will it work for other numbers then? Not necessary.
No, it won't work for, like, if the B is 2 and that is 4 and the min num is 2, then it won't work.
Yeah, just take care of this bucket num 0 wala case. You can put it then. I mean, the best way I'm thinking is just do this. must have a T1, right? Do a find and replace if you really want. Right?
Sir, instead of this, can't we simply eliminate the seal function and just use the bucket num?
Yes, that's a neater way. Yeah. Yeah, this will be a neater way of doing it. Correct. Don't you have find and replace here in the editor? Last one. Load then also. Now we will find the answer. Finally, let's say the answer is 0 to start with. One case you didn't take into account here is that if n is less than 2, you return 0, which is what is written here. Next, to find out the answer, what you can do is you can iterate over the elements of the bucket. How many buckets are there? You have 20 buckets. And take if max p I is and min pi is max. This is the case of empty bucket. Continue. Correct. You can start from 1 actually. And you can say that here, if the bucket is 0, you can say that your answer is nothing but that previous max is nothing but if that bucket is empty, we will have to skip all the empty buckets, right? First. So let's do it here only. So once I have a legit bucket, what I will do is, if this is obviously if I have, then I can simply say that my previous max is max b of I, correct? And otherwise, I can say is that my answer is max of my answer, comma, whatever is the min bi minus previous max. So I can optimize this code by not having this, simply having if max max is this, you can move this line out. Then I can return the answer. Any corner cases that I missed? For your case, Meet, when you have all zeros, it will take care of this, right? If you have same numbers, so you have just one bucket, this will be fine. Bucket size will be 1, and all these will be 0. You will just keep putting them. Yeah. Let's see. There is some issue. We will have to see. Where is the issue, Max?
Sir, the B is the size of the bucket, right? Or is
Yes.
it the total number of buckets?
B is the size of the bucket.
So while declaring the maximum B, you have made it size B.
My mistake. Correct. So how many buckets will be there?
I think it should be maximum divided by B.
So your total number of bucket. Let's do that. Number of buckets will be I think max on B, right? Is this right, Slok?
I don't know. I think so. Like this was nudging me from the beginning. I didn't know if I was correct or wrong.
No, no. What you are saying is correct. I'm just saying is the formula to calculate the number of buckets, right?
Yes, sir.
This is still not right. Not help in this case, I guess. Okay, let's see. अरे यार debugger लॉक कर रखा है. It's only for premium. Which input is this? This is 3691. You can debug. I will be debugging. If you want to see this, you can see. Otherwise, I'll just. One of the simplest ways of debugging is that you put print statements other than debuggers. You can obviously do debug using a GDB. This would be fine. This is not. I don't think there is an issue here. Let's print it. Even though. All right. Let's print this value. Let's print this. Let's see, and then maybe we can print something here. But let's see till here. What is the issue? So my min and max are 1 and 9, which is fine. Then my bucket size for this, theoretically, it should be 8 by, bucket size is also fine, right? What is the bucket size? It's 2. So if you have 2, you will have 4 buckets. 1 to 2, 3 to 4, 5 to 6, 7 to 8. That's the mistake. The bucket size calculation, this is wrong. This is wrong. Okay. This is wrong, basically. Will this be a seal? What did I do? I did 8 by 4, which is 2. So this number of buckets will basically be, if you have 2 sized buckets and you have from 1 to 9, how many buckets you will need? You will need 3, 4, 5, 6, 7, 8. Right. Will there be a +1 here? This line is faulty, basically.
Max num minus min num plus 1 divided by b.
And seal still, you will have a seal, or I can skip all this.
I think you can skip it. Like that is not needed.
Let's try what you're saying. You're saying I will skip all this. Just this much. Might run for this case, might not run otherwise. What happened suddenly here? Is the number of brackets less? No. तो बचा भी है 34 people still. What is the compilation issue here? No matching call function for call to max, because seal returns an integer, right? Both of them should be integers.
Sir, there the float should be for the complete thing. Like here, float we are keeping only for maximum minus minimum.
Okay, so
There should be one more bracket.
why?
It should be for maximum minus minimum num by n minus 1, right?
No. This float is fine. It will run now. I guess there was one more bracket. There was an extra bracket. Or no. So you are saying this, SSV, is it? You are saying I will put a float for, but why? Why do you say this?
So because max num minus minimum num will be obviously an integer, right? We
Yes.
have to check the float for the complete thing.
No. Max num minus min num will be an integer, and minus 1 will be an integer. If I don't typecast any one of these to a float, then the division will be an integer division. So then the seal will not make sense. It will always be return the same, right?
Yeah.
So not that, but there is something else. You will have to put a float anyways. Here you have to float a float if you want to seal it. You can skip putting a float outside. That should be fine. Okay, let's do it this way. This ceiling is definitely not right. It will be a floor. If this ceiling is there, then it will never become 0. Let's see. You guys are submitting from this account? Are you guys trying from this account? I don't know. Because this is our account that we use. So maybe you are submitting from this account, because I did not do this 9 hours or 2 hours ago, which is fine. So B is this, number of buckets is, it's, the bucket index is wrong. Definitely not be a C. Equals, make it a floor. No, the calculation is not wrong here. The calculation is wrong here. This is, I don't need a seal here. Definitely I don't need a seal here. I think so. Let's try. This is the same issue, right? This will work for this case, but not this case. Number of buckets. But this will still be equal 4, 9 minus 1. This line is definitely wrong. There is no other mistake in this code other than this line. That's for sure. Can you help me out with this line? Meet, are you there? So let's just so you guys are already talking. Fuck, I didn't see anything. Mithali is saying try b plus 1. Let's try b plus 1. But b plus 1 will even make it less, Mithali. Plus 1 separately you are saying. चलिए ये भी करके देख लेते हैं. And then we can try to make a sense of it. ये वाला केस तो चल जाएगा, बट उसके बाद भी चल जाएगा, आई थिंक. Fuck. Finally, this is the culprit. Okay, now maybe we can try and make sense of this plus 1 separately. Can we हाँ भिजवाता हूँ मैं अभी deliveries. So what do you prefer, Mithali? Silk or cheese burst? Same pinch, cheese burst. So okay, let's finish this. Let's make sense of this line. Other than this line, everything is fine, right? So how do we make sense of this? Like, can anyone tell me? Let's see. So what we are saying here is that you have a minimum and you have a maximum. You have a gap, which is B. So max minus min upon B. If this will basically give me, so my claim was that this gives me the number of buckets. But this basically will give me 1 less than the number of buckets. That's what this plus 1 will give me, the number of buckets. So I just want to make sense of this in English. Anyone? Adding 1, then feel of this you are saying. No, this, if this is a perfect number, then also we are adding 1. If it is perfectly divisible, then also we are adding 1. We did that, right? We always did this. Max minus min. We wrote this as the number of buckets.
Sir, suppose all the numbers were consecutive, so max would be, and starting from 1 to 9, suppose. So max would be 9, minimum would be 1. Max minus 1 is 8, right? And the bucket size would be 1. So 8 divided by 1 would give us only 8 buckets, but we need one more, which is 9. So we'll have to add one more bucket, because we are getting the bucket size of only the gaps. We need one more, because and we are doing n minus 1 only there.
So what you are saying is No, but I got your intuition. You're saying that is fine. Like example is fine. It works, that we know. But like, how do you make sense of it? Last number रह जाएगा हर बार ना. हाँ. That's the thing. Last number, not always, when it is perfectly divisible.
Sir, what I mean to say is we are calculating gaps of n minus 1, correct? Like for n numbers, we'll have n minus 1 gaps.
Right.
So if we want bucket size, we'll have to add one more to it, so we can have each and every number over there. Otherwise, we'll have only 2 gaps for 3 numbers. We'll need one more.
Okay. Somewhat, yeah. What you're saying. I got what you're saying. What he is saying is that let's take that case when the numbers are evenly equally spaced apart, and if you count the total number of, if you apply this formula, what you will get is basically n minus 1. So you will get, but that should be your bucket count, right? Slope, why should that not be your bucket count? That's fine. Okay, I guess we should call it a day. Maybe we can discuss it in the next class that I will take. But that also did not work, Utsav, right? Max minus min gives one less, so this should work then, right? But this also did not work. Because here you're dividing by b and not 1. So to truly say that this is basically plus b, right? In the numerator and not plus 1. Yeah.
Sir, one more easy way out of this I could say is when we make the vectors maximum b and minimum b, we could just resize them to the size of the nums array. Like we'll have to ignore the rest, and that could be one way.
Come again. You said,
like if we ignore this calculating the number of buckets, and we just make the size of the maximum b vector and minimum b vector as the size of nums array, we could iterate through them, and if we get if at any point maximum b of I equals to integer max, then we could just ignore, we are already ignoring it. That way we will not have to deal with integer overflow, because number of buckets would always be less than the size of array, less than or equal to.
okay. I mean, you can try that. I got you. But yeah, you can try that. Okay. I guess we should end today. It's 1 a.m. Any more questions other than this? So cool.